If your old man was a Buick guy in the early 80s, there's a reason he still talks about it. Not the big block Chevys, not the Pontiac 455s, the Buick, the one with the Turbo 6. He wasn't exaggerating. 1978. Buick introduces a turbocharged 3.8-liter V6 in the Regal. On paper, it looked like a mistake. This was the era of big displacement. Muscle car guys measured worth in cubic inches, 350, 400, 455. The bigger the number, the better the bragging rights. And here comes Buick with a V6, a turbocharged V6. In what was supposed to be a performance car, the automotive press was polite, which is to say, they were skeptical. A V6 in a muscle car with a turbocharger? That sounded like something you put in an economy car trying to pretend it was fast, not something you race. But here's the thing about the Buick V6. It had history. The engine design went back to 1962, originally 3.2 liters. Buick sold the tooling to Kaiser Jeep in 1967 when they thought V8s were the only future worth chasing. Then the oil crisis hit. Suddenly, fuel economy mattered. Buick bought the tooling back in 1974, paid cash for their own old design. The engineers who got it back knew something the muscle car crowd didn't. Displacement isn't everything. Torque is. And the way you deliver that torque matters more than the peak number. See, a big V8 makes impressive horsepower, high in the rev range, where it sounds good, where it looks good on a dyno chart. But in the real world, on the street, from a stoplight, what matters is torque at low RPM, the grunt off the line, the shove in your back when you hit the gas at 30 miles per hour. That's what makes a car feel fast. And that's where turbocharging changes everything. A naturally aspirated engine breathes in air, mixes it with fuel, burns it, makes power. The amount of air it can breathe depends on the displacement. Bigger engine, more air, more power. Simple math. This is why the cubic inch wars made sense. In 1970, if you wanted more power, you made the engine bigger. But a turbocharger cheats. It uses exhaust gas energy that would otherwise be wasted going out the tailpipe, spins a turbine. That turbine drives a compressor. The compressor forces more air into the engine than it could breathe on its own. Suddenly, your 3.8-liter engine is breathing like a much larger engine. But only when you want it to. At cruise light throttle, the turbo barely spins. The engine acts like a fuel-efficient V6 because it is one. But when you floor it, the turbo spools up, boost pressure rises, and that same V6 starts making power like an engine 50% larger. The Buick engineers understood this before the muscle car crowd caught on. They tuned the turbo system for low-end response, not peak horsepower. Torque, lots of it, available early. The original 1978 Turbo Regal made about 165 horsepower. Not impressive on paper, but it made 285 pound-feet of torque. And it made that torque starting at 2,000 RPM. Compare that to a typical 455 big block of the era. Sure, it might make 350 horsepower, but peak torque came at 3,000 RPM or higher, and the engine weighed over 200 pounds more, and it drank fuel like Prohibition was coming back. On paper, the big V8 looked better. In a drag race from a standstill with professional drivers and perfect launches, the V8 would probably win. But on the street, real-world driving, that instant torque from the Turbo Buick felt faster, was faster in many situations. This was confusing to a lot of people. The car magazines would test a Turbo Regal against a Camaro Z28. The Camaro had the famous small block 350, more displacement, more horsepower, more street credibility. But the Buick would hang with it, sometimes beat it. Not because the numbers were better, because the power delivery was better. Here's where it gets interesting. Buick kept developing the Turbo V6 while everyone else was still arguing about displacement. 1982, they introduced sequential fuel injection on the turbo motor, made it more responsive, more reliable, better fuel economy, while Pontiac was still using carburetors. 1984, they added an intercooler. This is a radiator for the compressed air coming out of the turbo. Cooler air is denser. Denser air makes more power. The intercooled Turbo Regal made 200 horsepower and 300 pound-feet of torque. Still doesn't sound impressive by modern standards. But remember the context. This was during the malaise era. Emission controls had strangled most engines. A brand new Corvette in 1984 made 205 horsepower from a 5.7-liter V8. The Buick was making nearly the same power from an engine with 2 fewer cylinders and 2 liters less displacement, while getting better gas mileage. The V8 crowd still wasn't convinced. They looked at the specs, saw the V6, and dismissed it. Some things are cultural. You can't argue with cultural. But the stoplight races told a different story. If you're enjoying this, hit subscribe. We cover engineering stories like this every week. Okay, back to it. The Turbo Buick had a secret weapon that didn't show up on any spec sheet. It was called boost creep at low RPM. The way Buick tuned the wastegate and boost controller, the turbo would actually build boost faster than the engine could use it during initial acceleration. For a brief moment, right off the line, the little V6 was making more torque than the published numbers suggested. The V8 guys didn't know what hit them. They'd line up at a light, see the Buick badge, see the V6, and figure easy money. Then the light would turn green. The Buick would launch, and for the first 100 feet, it would pull ahead. By the time the V8 came into its power band, the race was often already decided. This drove the V8 purists crazy. There had to be something wrong. The Buick must be cheating somehow. A V6 can't beat a V8. That's not how physics works. Except it is. It's exactly how physics works. The Turbo Buick wasn't cheating. It was exploiting a fundamental truth about internal combustion engines that the displacement fanatics refuse to accept. Power is torque multiplied by RPM. To make horsepower at low RPM, you need massive torque. A big displacement engine can make good torque, but it also has big rotating mass. Big pistons, heavy crankshaft. It takes time to accelerate all that mass. Time you don't have at a stoplight. A smaller engine with forced induction can make equivalent torque with less rotating mass. It responds faster, revs quicker, gets into its power band sooner. And with a properly tuned turbo system delivering boost at low RPM, it can make that torque exactly when you need it. The Buick engineers figured this out. They didn't care about winning arguments in car magazines. They cared about winning at stoplights. 1986. Buick releases the Grand National. Same turbocharged 3.8, but refined. 235 horsepower, 330 pound-feet of torque. 0 to 60 in under 6 seconds. For context, a 1986 Corvette did 0 to 60 in about 5.8 seconds. A Ferrari 308 did it in around 6.5. The Buick, with its humble V6, was running with exotic sports cars, and it did it while looking like a mobster's getaway car. All black, blacked-out trim, no chrome, no flash, just menace. But the real party piece was still that low-end torque. The Grand National didn't feel fast when you looked at it. It didn't sound fast at idle. It sounded like a Buick. Because it was a Buick, but when you put your foot down, it would shove you back in the seat with a violence that didn't match its appearance. The turbo V8 cars of the era, like the Mustang SVO with its turbocharged 4-cylinder, had turbo lag. You'd floor it, wait a second, then the power would hit. The Buick had lag too, but less of it. The larger V6 had more displacement to work with, more exhaust energy at low RPM, faster spool-up. By turbo standards of the 80s, it was responsive. And the tuning community figured out pretty quickly that the Buick V6 was barely trying. See, the factory turbo system ran about 15 pounds of boost. The engine itself, with its cast iron block and forged crankshaft, could handle 25 pounds without breaking a sweat, 30 with some supporting modifications, 35 with good tuning and quality fuel. People were making 400, 500, 600 horsepower from these engines with bolt-on modifications. The V8 guys had a problem. Their engines didn't respond to modifications the same way. You could put a bigger cam in a small block Chevy, port the heads, add headers. Maybe you'd gain 50 horsepower, 80 if you really knew what you were doing. But the turbo Buick? Turn up the boost, add an alcohol injection kit to prevent detonation, and you'd gain 100 horsepower for a few $100s. It wasn't fair. That was the point. 1987. The GNX. Buick partnered with ASC McLaren to build 547 examples of the most audacious sleeper ever manufactured. From the outside, it looked like a slightly modified Grand National. From the inside, it felt like being launched from a catapult. Buick officially rated the GNX at 276 horsepower. This was a lie, a deliberate, legal, marketing department-approved lie. They rated it low because insurance companies used horsepower numbers to calculate rates. Lower official number meant lower insurance costs for buyers. Real-world testing showed the GNX making over 300 horsepower at the wheels, probably 330 to 350 at the crank. Torque was around 360 pound-feet. It would run the quarter mile in the low 13-second range right out of the box, mid-12s with minor tuning. The 1987 Corvette, 13.2 seconds in the quarter. The GNX beat it. A Buick with a V6. Beat the flagship American sports car. Car and Driver magazine tested a GNX against a Ferrari GTO. The GNX won. They tested it against a Lamborghini Countach. The GNX was faster in the quarter mile. Against a Porsche 911 Turbo, the GNX was quicker off the line. These were cars that cost 3, 4, 5 times as much as the Buick. Cars built by legendary manufacturers with decades of racing heritage. Cars with the best engineering money could buy. And they were losing to a turbocharged V6 from Flint, Michigan. The technology that made this possible wasn't exotic. It was clever application of existing principles. The GNX used a larger turbocharger with a ceramic impeller instead of aluminum. Ceramic is lighter and can spin up faster. It had a more aggressive camshaft, better intercooling, higher boost pressure. The exhaust manifold was redesigned for better flow. None of this was revolutionary. It was refinement. The result was an engine that made enormous torque at low RPM, then kept making power all the way through the rev range. The power band was broader than any naturally aspirated V8 of the era. It felt like the car had an extra gear hiding somewhere. And this, finally, is where the V8 guys had to admit defeat. Not publicly, never publicly, but privately, at the drag strips, at the stoplights, in the parking lots where reputations were made and lost. The Buick Turbo 6 had proven that technology beats displacement. It wasn't just about the hardware, it was about thinking differently. The V8 approach was brute force. Want more power, more displacement, more fuel, more everything. It worked up to a point. But it hit diminishing returns. You can only make an engine so big before it gets too heavy, too thirsty, too hard to package. The turbo approach was leverage. Use waste energy to multiply what you have. Make a smaller engine act bigger when you need it, smaller when you don't. It was smarter, more elegant, more efficient. The automotive industry took notice. The lessons from the Buick Turbo V6 influenced engine development for the next 3 decades. The modern push toward small displacement turbocharged engines started here. Not in Europe, not in Japan. In Flint, Michigan, in the mid-'80s, with an engine whose tooling had been sold off and bought back because the company thought V8s were the future. Today, the Buick Grand National and GNX are collector cars. Prices have climbed steadily for 20 years. A clean GNX will cost you 6 figures because people remember what they could do, what they proved. The Turbo V6 outlived the cars that made it famous. After the Grand National and GNX ended production in 1987, The engine continued in various forms. It powered front-wheel drive Buicks and Pontiacs through the 90s. Then it evolved into the supercharged 3.8 that went into the Bonneville SSEY, the Regal GS, the Riviera. Different forced induction, same basic architecture. The fundamental design concepts that made the Turbo V6 great remained relevant. Strong bottom end, compact packaging, responsive boost, good torque at low RPM. These weren't temporary advantages, they were principles. When manufacturers started downsizing engines in the 2000s, they applied the same logic. Ford's EcoBoost, Chevrolet's Turbo 4, BMW's turbocharged 6s. Different implementations, same philosophy. Make a smaller engine work harder when you need power, sip fuel when you don't. The engineers who developed those modern engines studied the Buick. Not always directly, but the ideas were there in the literature, in the tuning forums, in the cultural memory of an industry that had seen a V6 humble V8s for a decade. And that's the legacy that matters. Not just that the Buick Turbo 6 was fast. Lots of engines are fast. What matters is that it was fast in a way that forced people to reconsider their assumptions. The V8 guys thought they knew how cars worked. Displacement was destiny. More cubic inches meant more power, meant faster cars. This was gospel. This was law. This was carved in stone. The Buick Turbo 6 broke those tablets. It showed that an engine could be efficient and powerful. That technology could multiply the effect of displacement rather than replace it. That the smartest solution isn't always the biggest one. If you've worked on one of these, or you've been beaten by one, or you just remember seeing them at the drag strip in 1987, I want to hear about it. Drop a comment. And if you made it this far, go ahead and subscribe. We do this every week.